Okay, we just wanted to look at the idea of stationary points. Hopefully this is a little bit of revision. But to begin with, we just want to talk about the vocab here, because when we talk about stationary points, it's exactly the same thing as when we're saying turning points, and the same thing as local maximum or minimum points. We do have to talk about local as opposed to just maximum or minimum, because, as we know, the function below, even though it has a local maximum and minimum, which are the stationary points, it actually has global maximum and minimum at different points. Okay, so we just have to be careful with that. Okay, so let's just talk about finding stationary points. We should know how to do this. Mainly I want to do this because I need it for the next part of what we're looking at. So if we've got this function, y equals x cubed minus 3x, we need to find the derivative to start with. And once we find the derivative, then we need to be able to factorize that to find out when is this equal to 0. So turning points occur when the derivative is equal to 0. And so we're going to factorize this, which we can then use a difference of 2 squares. Which means we know that the roots of the derivative are 1 and minus 1. If we did a little sign diagram of this, okay, at the points minus 1 and positive 1, this can kind of help us to work out whether it's a maximum or minimum. Okay, now we're assuming that we don't have a graph of this. If we had a graph of it, we wouldn't worry about doing a sign diagram, but bear in mind for the first test, you won't have a graphics calculator. So graphing it sometimes is trickier than just doing a sign diagram. So we want to work out what's going on here, here, and here. So to do that, I just pick a point in my derivative and substitute in. So I'm going to pick, okay, let's say when x equals minus 2, okay, down here. What's the derivative doing? Well, I'm going to substitute back into this. Okay, so y is equal to 3 times minus 2 squared minus 3 is 3 times 4 minus 3, which is obviously, and I don't actually care about the number, do I? It's going to be 9. Don't really care about the number. All I care about is whether it's going to be positive or negative. It's going to be positive. I want to check between minus 1 and 1 in here somewhere, and the easiest number is going to be 0. So I'm going to pick 0 when x equals 0. Y equals 3 times 0 squared minus 3 is obviously going to be minus 3, which is the important part, negative. And I'll check one over here as well, just 2. When x equals 2. Sorry. This is the derivative. It's important to substitute into the derivative, not the function itself, because I'm caring about whether it's positive or negative, increasing or decreasing. Okay, so the derivative is going to be the same as it was before. So positive. Okay. Alright, so I then know, based off the fact that, well, this is increasing, this is decreasing, and this is increasing, that this here, if I draw this and join them up, is going to look something like this, where this is a maximum and this is a minimum. Okay, so I can now make the statement: a local max occurs at x equals minus 1, and local min occurs at x equals 1. Alright, straightforward. Okay, we want to just have a slight expansion of that, because we do want to talk about increasing and decreasing functions. Now, this has obviously got periods in which it's increasing and parts in which it's decreasing. So all we're doing for this is just really using the local maximum minimum to then describe the function in terms of increasing, decreasing. So for this one, I'm going to say, okay, it was decreasing over the interval. Let's have a look. Decreasing means that we're looking for anywhere that is negative. So it's decreasing between -1 and 1. And it's increasing anywhere other than that. So I'm going to say that when x is less than or equal to -1, and when x is equal to or greater than +1. Now, just it's better to write those two separately. You can try and get fancy with trying to use not symbols, or you can just write them two separately if they're left and right of another interval. Write two separate inequalities. Okay, so that's stationary points, turning points, local minimum, maximum, and increasing, decreasing functions. And really, this is just about determining what is going on with the function and being able to describe it accurately.